Alright, now let's talk about some different poker hands. We'll focus in this video on poker hands called flushes and straights. Let's start with a straight. A straight is a poker hand where the values are all consecutive. Not all of the same suit. It doesn't matter if they're 4 different suits or 2 different suits or 3 different suits. But if the values are all in order, like 1, 2, 3, 4, 5, and again, it doesn't matter if you shuffle your hand and show the cards in another order, this collection of cards is called a straight because it contains consecutive values. In this case, ace, 2, 3, 4, 5. And sort of a peculiar rule in poker is that ace, which usually is 1, could also count as sort of a 14. So we could have 10, jack, queen, king, ace, 10, 11, 12, 13, 14. So the ace could be 1 higher than king, or it could be 1 lower than 2. So this counts as a straight also. But the fact that ace can be consecutive to king and can be consecutive to 2 doesn't allow it to be used simultaneously. So queen, king, ace, 2, 3 does not count as a straight because the ace can be counted as the high card, higher than king, or the low card, lower than 2, but not both at the same time. So this sequence of cards does not count as a straight. Now if we have 5 cards that are all the same suit, this is called a flush. As long as it's not also a straight. If we have a hand that's a straight flush, that is consecutive cards all of the same value, then that's different. That's a straight flush. So we need to count, let's see, here's a straight flush of diamonds, 5, 6, 7, 8, 9 of diamonds. So that combination is even more special than any of the individual properties, the straight property or the flush property. So let's count straights which are not flushes, flushes which are not straights, and then the hands which are straight flushes. So a straight is consecutive values. Not all of the same suit. So those could be ace, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, etc. And the last possible straight is the one that ends with ace. 10, jack, queen, king, ace. So the number of starting points is 11. I'm sorry, the number of starting points is 10. Ace through 10. So we'll choose one of 11 starting values, and then that completely determines one of 10 starting values, 1 through 10. And that completely determines the values of the following cards. This plus 1, this plus 2, this plus 3, etc. Then we could have any collection of suits, 4 choices, 4 choices, 4 choices, 4 choices, 4 choices. That's 4 to the 5th, except we're not allowed to have them be all of the same suit, because that's a different hand. So 10 times 4 to the 5th minus 4 poker hands are straights. And then we've got flushes, which is the same suit. All the cards are the same suit. But not consecutive values. But not 5 consecutive values. So example 2, 4, 5, Queen, King of spades is a flush. So for the number of these, a flush is cards of the same suit. So there's 4 different suits that we have to choose from. And then we have 5 values to choose from. So 13, choose 5 values, except we don't want this to be 5 consecutive values. We said there's 10 ways to choose consecutive values, beginning with an ace, beginning with a 2, beginning with 3, etc., beginning to 10. So minus those 10. So there's 4 times 13, choose 5, minus 10 flushes. Alright, so now we've got the special combination of a straight flush. So again, that's 5 consecutive cards, say 6, 7, 8, 9, all of the same suit. But actually, if those 5 cards of the same suit and in order are 10, Jack, Queen, King, Ace, then that counts as a very special straight flush, which is called a royal flush. So let's look at the poker hand, which is a straight flush, but not a royal straight flush. So 5 cards of consecutive values. But those consecutive values can't be 10, Jack, Queen, King, Ace. And all 5 are have to have the same suit. So how many of these are there? Well, since they have the same suit, we have to pick one of the 4 suits. So that's the suit for all 5 cards. And then we have consecutive values, which are determined by the starting card, which could be ace through 9, but not this sequence because that's something special. Alright, and now for the rarest poker hand of all. We've got a flush, which is simultaneously a straight and has the highest possible values for a straight. 10, Jack, Queen, King, Ace. This is called a royal flush. So royal flush is 5 cards of consecutive values. Not just any consecutive values, but of the consecutive values must be 10, Jack, Queen, King, Ace, all of the same suit. So the number of these is 4, because once we choose the suit, the values are determined. It has to be 10, Jack, Queen, King, Ace. So there's one royal flush that's spades, one just like this that's hearts, one just like it that's diamonds, and one just like it that's clubs. So this might be the hardest poker hand to get, but it's the easiest one to count. There's only 4 of them. Alright, now let's use the subtraction principle to find all the poker hands that don't have any repeated cards and don't have any of the flush or straight properties. Let me call these uninteresting poker hands. So no repeated values. Not 5 consecutive values. And not all the same suit. Alright, at the end of the last video we counted the number of poker hands that had no repeated values. So that was 13 choose 5 values, 5 different values, times 4 to the 5th suits. Then we want to subtract off the special cases of this that were something nice, like a flush or a straight. So the number of flushes we said was 4 suits times 13 choose 5 minus 10. Those are flushes that are not including the straights, which is why we subtracted 10 here. And then minus 10 times 4 to the 5th minus 4. Those are straights, not including the straight flushes, which is why we have the minus 4 here. Minus 36 straight flushes, minus 4 royal flushes. Alright, so this whole expression of 13 choose 5 times 4 to the 5th minus 4 more expressions is the number of poker hands that don't count really for anything. Not pairs, not 3 of a kind, not 4 of a kind, not a flush, not a straight of any type. Alright, now study all of these poker hands and how many of them are, because these are really nice and kind of difficult counting problems. And if you can count these correctly, you can probably count anything correctly. The end.